Hey all my dear students, welcome back again to H.S.P in World of Chemistry. You must have seen this table in the previous sessions, right? But right now, today I'm going to tell you how fundamentally and technically you can get this table in your hippocampus. So let's it go and I will let you know. Now, first of all, if you see the word SN2, whenever the word is coming SN2 in front of you, remember that this 2 means that bimolecular nucleophilic substitution reaction. What does it mean? That when the reactant, when the reagent both are involved in the rate determining step. That means it will follow second order chemical kinetics with respect to the reactant, the power is 1, and as well as with respect to nucleophile also the power is 1. So it will follow second order chemical kinetics. That means both your reactant and nucleophile are involved in the rate determining step. ये दोनों के दोनों rate determining step में involved हैं और ये कब होगा? When it is going to happen? That when the reaction is going to take place in single step. Remember that. This can happen only once the reaction is going to take place in single step. So remember that whenever 2 is written, remember that it's single step reaction. And this is possible only when both the reactant and reagent, or if I talk about E2, both the reactant and base, they are involved in the same step. So SN2 single step, E2 single step. One thing is clear. Now, any reaction to take place in single step, the attacking agent should be strong or weak. If you want to do anything in one go, you should be strong or weak. Definitely you should be strong. If you want to carry one table from one place to another place, one chair from one place to another place, you should be strong enough. Then only you can keep it from one place to another place, right? So the nucleophile for SN2 and the base for E2 must be strong. Then only it can do work in single step. Now how to find out that is strong or poor or weak? Remember that if it is like this, R O negative, RO negative can be written RO negative, or along with that Na plus or K plus can be there. That means the bond must be ionic. This bond must be ionic. Then RO negative will be RONA can be written over there, ROK can be written over there. Then this is going to be strong. One point is very much clear. So strong nucleophile will do SN2, strong base will do E2. Now for that, the reactant must be least sterically hindered. Remember that reactant must be least sterically hindered. For what? For SN2. For SN2, the reactant must be least sterically hindered because it has to attack from the back side. The attack, because simultaneous breaking and making of bond, as I have told you, SN2 means single step reaction, and single step reaction means simultaneous breaking and making of bond. So attack of nucleophile will be from the back side, and back side must be least sterically hindered. So it must be 1 degree or 2 degree, but 1 degree is better, right? Because in 2 degree relatively steric index will increase, in 3 degree so no space will be there from back side. Are you getting my point? So definitely I can say 1 degree, 2 degree, 3 degree, like that. One point is very much clear. So reactant must be least SH, sterically hindered, and nucleophile must be strong nucleophile. This page is clear. Now let me move towards SN1. If you see SN1, this 1 is written. 1 means unimolecular reaction, unimolecular nucleophilic substitution reaction. Now 1 means that only one of the entity is involved in rate determining step. If only one entity out of 2, because one is reactant, another one is reagent, out of 2 reacting entity, only one is involved in rate determining step. That means in the rate determining step, nucleophile is not involved How it is possible? That means the reaction is taking place in more than one step, then only in the rate determining step one is involved, nucleophile is not involved, and nucleophile must be involved in some other reaction. That means this reaction will take place in more than one step. So it is a complex reaction and multi-step reaction. This is multi-step reaction, and this will proceed with the formation of intermediate, and intermediate is carbocation. So rate of reaction, FOR, no, it's not FOR, it's ROR. So rate of reaction, let me write down clearly that rate of reaction is directly proportional to the carbocation stability. So reactant should form more stable carbocation. Why? The base is weak and polar protic solvent. The reagent is polar protic solvent, so it will form carbocation. So better is the PPS. More easily the carbocation will be formed, but at the same time reactant must be willing to form carbocation. Its carbocation should be stable. So it's simple, SN1. Now remember that whenever SN1 is taking place, same tendency I can say about even also. Even one, that means multi-step reaction and carbocation stability. So one thing is clear, are you getting my point? That definitely temperature will promote elimination reactions. So whenever SN2E2 single step reaction, whenever SN1 even multi-step reaction, and whenever multi-step reaction, rate of reaction will be dependent on the stability of carbocation. This point is clear. So let's see reactant. In front of you, just see the reactant. This is 1 degree. How to find out it is 1 degree? My dear students, the carbon to which halogen is attached, if that carbon is further attached with one more carbon or no other carbon, that means it is 1 degree. Now 1 degree, just see, you will see that on this carbon something is attached from the back side. Don't see like this. You have to see it like this, that the carbon is there, one hydrogen is coming towards observer side. Always see the three-dimensional, one hydrogen is going away from observer, and one methyl is there, and this is Br. Always see to it like this. That means its ABMO is naked. The attack will, the nucleophile, and see what type of nucleophile it is there, O negative, Na positive, and this bond is being ionic. So it will attack in one step. It is SN2 reaction, single step fast reaction SN2. I hope it's clear. Now if you see the second reaction, if you focus on the second reaction, my dear students, this reaction, the carbon to which halogen is attached, which is the leaving group. Now see, this is methyl, this is methyl, this is methyl. No place to attack from the back side. It is sterically hindered, and it is your 3 degree alkyl halide. So it cannot attack from the back side. Back side attack is not possible at all. Now what to do? But see here, it is negative, it is positive, it is strong. It is strong, either nucleophile or base. Nucleophile it cannot be, because backside space is not there. So definitely it will do anything in single step. Definitely it is single step reaction, but single step reaction SN2 is not possible. It has to, base is saying I am being strong. Whatever I will do in single step, but backside space is not there, so no SN2. Then what is left? Only E2 is left. So only E2 reaction will take place, my dear students, and that's why only elimination will take place. E2 means, E means elimination, SN means substitution. Elimination will form alkene, and substitution generally will form ether. And here only alkene will get formed, and that's why Williamson said never take 3 degree alkyl halide if you want to prepare ether, because here ether will not get prepared. Now if you see the another reagent as well as the reactant, you see the reactant is your benzyl bromide. Let me move aside benzyl bromide. You see it is 1 degree. This is strong. Strong is saying it is 1 degree, so I will do only SN2. But at the same time, if you see water, water is being weak. It is covalent bond. It will say I too cannot attack in single step. So he will say, water will say, I am being weak. I would like to form carbocation. Do you think your carbocation is stable? Yeah, sure. My benzyl carbocation is resonance stabilized. Now it is stabilized by resonance. It indicates that yes, single step reaction or multi-step reaction. Sir, I am unable to understand. See, reactant is 1 degree. It is saying I can show single step reaction because not sterically entered. But water you cannot attack in single step. You always want to form carbocation. Your interest is you love forming carbocation. So carbocation once formed, that means multi-step reaction. So it is SN1. Remember that SN1. So benzyl bromide as well as same happens with allyl bromide. Whenever allyl or benzyl is given, remember that they can show both SN2 as well as SN1. It depends on the type of nucleophile. If in place of water by chance they have given alcohol ROH, then also same reaction will take place with water or alcohol. It will show SN1 reaction. I hope this is clear. Now if you see that this halobenzene, its lone pair is doing resonance with this benzene, that's why its bond length decreases by 8 picometer and it is attached to sp2 hybridized. It will not leave. So neither SN1 nor SN2 nor even E2, nothing. It will not show any reaction at room temperature. No reaction at room temperature. Room temperature, no reaction. Now if you see the second one, this is 1 degree with the eye of strong nucleophile. So SN2 and this is water, or if you put ROH, then you see its carbocation is stabilized by back bonding. Now number of students are doing mistake at this place. Why? They are forgetting that its carbocation is resonance stabilized. In the examination, 99% people will forget about that this oxygen is having lone pair at 2p and its 2p will be vacant. 2p pi back bonding, super awesome back bonding, excellent baby. And back bonding is 2 atom resonance. So here it will show SN1 declared. Now if you see the next one, there you see upper one, the oxygen heteroatom was present at alpha carbon, but here alpha beta. So no resonance is possible. Oh, sorry. No resonance is possible, you see. So I will not say here the SN1 take place. No resonance stabilization. So no SN1. But here it is 1 degree. So definitely SN2 will take place. I hope till now it's clear. Now see, this is going to follow Braddock's rule. If it is saying I will attack on one stack, it is 3 degrees, so no SN2, no SN2. Now it is saying I will form carbocation, but remember that this carbocation is not stable, not stable, not stable, so will not get formed because it will violate Braddock's rule. What is that Braddock's rule? Braddock's rule says that bridge head carbon can't be sp2 hybridized. If you don't want to apply anyone's rule, you can see if it is sp2 it should be planar. If it is planar, its bond angle must be 120 degree, and if it is going to form 120 degree, the ring will break. So 120 degree formation is not possible. So this compound does not exist. So no SN1, neither SN1 nor SN2, and neither E2 nor E1, because if you put here double bond, once again Braddock's rule will get violated because double bond. If it is coming over here, it will become sp2 hybridized, and that is not possible. So E2 is not possible, E1 is also not possible. So it will not show E1, E2, SN1, SN2. Now, my dear students, if you see these reactions, this is 2-degree alkyl halide, 2-degree alkyl halide, and this is negative and positive strong. I will say it is strong. If you consider it to be nucleophile, it is strong nucleophile. If you consider it to be base, it is strong base as well. Now remember that strong will do whatever the reaction it will do in single step. So single step substitution is SN2 and single step elimination is E2. Remember that 2-degree alkyl halide, whether the temperature is mentioned or not, it will always do elimination more. So 60% elimination E2, it is given in NCERT, and 40% substitution SN2. If you give temperature, then elimination amount will keep on increasing. Remember that. Okay. Now, generally people must have studied that if temperature is given, then only elimination is going to take place. Even at room temperature, elimination will take place. Don't do this mistake. 99.99% people are doing this mistake. They are considering only whenever the temperature is provided, they are doing E2. Even at room temperature, elimination will take place, and that is more in 2-degree alkyl halide. So whenever strong nucleophile is given, 2-degree alkyl halide will show simultaneously both substitution as well as elimination. Elimination will be more. Now if you see, this is covalent bond, so it is weak nucleophile as well as weak base, so it cannot attack in single step. And 2-degree carbocation is stable, so first carbocation will get formed. So SN1 SL as well as E1, examiner will not ask whether E1 is major or SN1 is major. So see what is written. Secondary alkyl halide will always show elimination as well as substitution parallelly, parallel reaction. If it is strong, then SN2E2. If it is weak, then SN1E1. Now next, this is your tertiary butyl bromide, and if you see, this is negative and positive, it is strong. But remember that it can't show SN2 because 3-degree is sterically hindered, so only E2. And here carbocation, because this is covalent bond, so poor and polar protic solvent, so SN1 as well as E1 both. I hope you are getting my point. Now see, this is 1-degree and this is strong, so SN2 only, and that's why Williamson said that whenever you want to prepare ether, always take least sterically hindered alkyl halide, so it will give very good yield of ether. Very good yield of ether. And you see, this is poor, and it will try to form the carbocation, and carbocation is not stable, so negligible reaction, negligible. Now my dear students, now let's reach to the table and try to understand that table what I have written. See, everyone can understand this table now. If you see, let me move a little bit side so that you see 1-degree likes SN2. Allyl and benzyl loves both SN2, because if nucleophile is strong, then SN2, and if nucleophile is weak, then SN1. So if strong nucleophile, then single step reaction SN2, and if the nucleophile is polar protic solvent and poor or weak, then SN1. How to find out? See, these are strong nucleophile. First of all, see strong nucleophile. How will you identify strong nucleophile? And how will you identify poor or weak nucleophile? First of all, you should consider strong nucleophile will do single step reactions. So that first choice is SN2 and E2. You must be getting strong nucleophiles. First choice is SN2 and E2, right? And poor and weak nucleophile, they are due loving SN1 in E1, right? First categorization is clear. When the nucleophile is strong or very strong, they will do SN2E2. Their choice is SN2E2. Whenever the nucleophile is poor or weak, their choice is SN1E1. Now see, this is 1 degree least sterically hindered, so it will always try to form SN2, but for that nucleophile must be strong. Now if you see 3 degree, let's come to the 3 degree alkyl halide. Now 3 degree alkyl halide, if you are getting a strong nucleophile, that can't do SN2. SN2 is not possible, so only E2. So 3 degree is loving only E2. You see 3 degree is doing only E2. What if at the same time nucleophile is poor or weak? It will form carbocation, so it will form SN1 E1, and you see SN1 and E1 both. So 3 degree alkyl halide can never show SN2. So see, the arrow is not coming from SN2. No arrow is coming from SN2. You can see. Now, if you see this 2 degree alkyl halide, 2 degree alkyl halide, it is having equal probability to go all 4 types of reactions. So, which 2 reactions 2 degree alkyl halide will show, that will depend on the type of nucleophile or base. If it is being strong nucleophile base, 2 degree will show SN2A2. If it is being poor or weak nucleophile, it will show SN1 and E1. I hope the chart is very much clear to all of you. This is the best mind map, and it's given in the box of NCERT. That's substitution versus elimination. That is the race, and this is all about. How much you have liked it, do let me know in the comment section. Then I will bring number of videos, mind-blowing videos like this. And if you're new to this channel, subscribe this channel, right? Baba H.S.P is MTech and MSc gold medalist, GRF GATE and MTech, right? 2004. Produced first rank, third rank, fifth rank, many rank. Bye bye, Tata, take care, everyone.